Hello friends, hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to start with a new playlist of solved questions of navigation. So these questions will be from Oxford Navigation textbook. We will solve all the back questions of this chapter. So today I have selected chapter 14, which is Convergency chapter, and if you open that chapter and there are a list of some 8 to 10 questions. So we will solve each and every question one by one with detailed analysis and conceptual clarity. So all you need for this lecture will be a notebook, an Oxford textbook, Oxford PDF, okay, and a prior understanding of convergency chapter. So do watch the video on convergency, read the chapter on convergency, and then it will be easy to solve this sum. So let's begin with chapter 14, chapter number 14, convergency, question number 1. So the convergency of the meridians passing through points M, Mike and November, which are in the southern hemisphere, is 12 degree. So convergency is 12 degree. If the rumline track from M to N is if the rumline track from M to M is 249 degree, what is the great circle track from M to N and N to M? What is the great circle track from M to N and N to M? So rumline from M to N is 249. Okay, so let's solve this sum. We are in the southern hemisphere. So rumline from M to N, Mike to November is 249. Now 249 is what direction, tell me? 249 is the direction of southwest. So that means when we start from Mike to November, going from Mike to November, we are going in the southwest direction of 249. That means Mike is somewhere here, November is somewhere here, and that M to N is 249 degree. Now we know that in southern hemisphere, the great circle will pass through the nearest pole. Okay, so it will go from, if this is your south hemisphere, so it will go near from the south pole. Now we have been given, if you know, this is rumline, this is great circle, okay. M to N rumline is 249. So we will draw an angle from this line, vertical line, which is a meridian, to the rumline. So that is 249. Next, convergency is given to us 12 degree. Now when convergency is given to us, we can definitely find convergency angle. So convergency is 12 degree. Therefore conversion angle will be half of convergency, which is equal to half of 12. So convergency angle will be 6 degree. So now we know convergency angle is the angle between rumline and great circle track. Correct? So let's write 6 degree here. So convergency angle is 6 degree. 6, 6. Okay. Now with this, now we have two information on this side of the diagram. We have rumline 249 and we have this 6 degree angle. With this data of two values, 249er and 6 degree, we can find easily just by simple mathematics great circle track starting from M going to N, Mike to November, which will be rumline track from Mike to November minus convergency angle. Why? Now see, rumline track is the entire big angle. Okay, and to find great circle we only need this much part. Only we need a part of that rumline total angle. and that great circle part we will get by subtracting the whole Ramline angle minus 6 degree. We will be left with only great circle part, that brown dark red color. So let's substitute the values. Ramline track M to N was 249, convergency angle is 6. So our great circle from M to N will be 243 degrees. 243 degree. Okay, so that is part 1. We had to find out great circle track from M to N, that is done. And then from November to Mike. Now, next part. Now we know that Ramline track from Mike to November was given to us, which was 249. Therefore, Ramline track from November to Mike will be Mike to November straight line, it was 249er. November to Mike, if we follow this Ramline straight line, it will be the reciprocal of that. So it will be reciprocal of 249er. Therefore, I'll write it down again. Ramline track from Mike to November minus 180 degree equals to Ramline track from N to M. Therefore, Ramline track from N to M equals to 249er minus 180, which is equal to using a scientific calculator, it is 069er degree. So that is the next part of the answer. Okay, 06. So only this part is 069er degree. Okay, that is your for N to M Ramline. Okay, now how to know that whether to subtract minus 180 or plus 180? If you want to find a reciprocal of any direction which falls between 0 and 180, 0 to 180, add. Okay, 0, you have to add. If any number falls between 180 to 360, that is 0, you have to subtract 180. Okay, so 0 to 180, add 180. So I will write down for your better understanding. Any number less than 180, add more than 180, subtract. Okay, this is how you find a reciprocal of any direction. If the now here the direction was 249er, which was more than 180. So to find a reciprocal of that, we had to subtract 180 from that. Now next part is to find great circle from November to Mike. It is very simple. Now great circle from November to Mike will be this angle. Will be starting from here, this Ramline part plus another convergency angle part. Okay, so Ramline part this much till here, and then again this another additional part of 6 degree. So great circle N to M will be equal to Ramline from N to M plus the convergency angle. So what is Ramline from November to Mike? It is 069er. Convergency angle is 006 degree. Therefore, great circle N to M will be 075 degree. Okay, 075 degree. So this is how you do the sum. This is the final third part of the answer. So we were told to find great circle track from Mike to November and November to Mike. But to find great circle track from Mike to November and November to Mike, we have to first find rumline tracks, okay, of November to Mike and convergency angle. Okay, so eventually you have to solve the whole sum. So this is how you do it. Let's go to next question number 2. Bearing of B at 30 degrees south from A, which is also at 30 degrees south. So both points are located at same latitude. Very simple sum then. Is 100 degree true. What is the great circle from B to A and what is the longitude of position B? So let's start doing question 1A. Now since both are at same latitude, that means both are at the same latitude, so next to each other, separated by a particular longitude. Now let's check whether A will be here or here. The great circle bearing of B from A. So B from A means you are going from A to B. So A to B, the direction of A to B, if you have to go by great circle, you are going to follow 100 degree true track. So that means 100 degree, if this is your north hemisphere, if this is your south hemisphere, this is your east and this is your west. So 100 degree will be southeasterly direction, right? Southeasterly direction. So you are going in the southeast direction. That means A will be here, B will be somewhere here. Okay. To go in the southeast direction, you must start somewhere from the northwest, from this side, right? So that's why A and B is A will be here, B will be here. This is how you check where A will lie, where B will lie. Next, since it is a southern hemisphere, the great circle goes from near the southern pole. Now A and B are on the same latitude. So when latitudes are rhumb lines, right? And rhumb lines have easterly or westerly directions. Okay, if you follow a particular rhumb line, you can either go east or you can either go west, constant direction. So now in this case, rhumb line, this is your rhumb line, this is your great circle. So let's write down the description of this diagram. Rhumb line from A to B is how much if you want to go from A to B following a rhumb line or latitude. It is what direction? If this is your north direction, that will be your easterly direction. So A to B is 090. Rhumb line from B to A is how much if we want to go from B to A. That is your westerly direction. So reciprocal of 090, 270. So this is your 090. This part is your 270 rhumb line. Now the question is given that great circle from A to B is 100 degree. So A to B, this great circle is how much? 100 degree. So let's write down the next point. Great circle A to B is 100 degree, right? Now we have two pieces of information here. Rhumb line A to B, great circle A to B. Now the angle between great circle and a rhumb line is a convergency angle by definition. Okay, convergency angle can either be half of convergency or it can be the difference between the rhumb line and great circle. So rhumb line A to B and great circle A to B, difference between them 100 minus 90 is 10 degree. So let's write convergency angle 10 degree here, 10 degree here. Now it is very simple to find great circle track from B to A. So great circle track from B to A, as you can see from the diagram, it is only up to this point, just like the previous one, only up to this circle. So rhumb line is this entire angle. From that big angle, we will subtract this convergency angle. We will be left with the remaining part of great circle B to A. So rhumb line B to A minus convergency angle. which is equal to 270 minus 10 degree. Therefore, great circle B2A will be equal to 260 degree. So this is the answer to part 1. Great circle B2A will be 260 degree. The bigger angle minus smaller angle. Okay, 260 degree. Okay. Remember also one thing, you can see how it can decrease or when will it increase is that when you go towards right hand side or when you go in clockwise direction, angles increase. When you go in anti-clockwise direction or when you go towards the left hand side, okay, angle decrease. Okay, anti-clockwise. Now look at this diagram. There is another way to know whether to subtract or add. Rum line is to the right of great circle, right? Is to the right of great circle, or if you go clockwise, you will reach rum line from great circle. So that means clockwise means increase in angle. Therefore, rum line will be more than great circle. And therefore, if you want to find out great circle, you have to subtract convergency angle from rum line, and therefore you will get great circle. Okay, so you can see here great circle is to the left hand side of rum line or anti-clockwise of rum line, and therefore you have to subtract something to obtain great circle. So next, let's find question number B. I will erase this. So remember these points, note these important points for your next sums. Find out the longitude of position B. Very simple. Use convergency formula. D long in degree into sine of latitude. Now convergency is how much? Convergency is twice of convergency angle. Convergency angle was 10 degree. So convergency will be 20 degree. So 20 equals to D long. I don't know the difference between two longitudes here because we have only one longitude. So D long remains as it is. Sine of latitude. Both are at same latitude of 30 degree. So D long equals to 20 divided by sine 30, 20 divided by half, which is equal to 40 degree. So D long will be 40 degree. That means the difference between two longitudes is 40 degree. So A is at, so let's draw this diagram again. So A is at longitude 165 east, and we are going A to B. So we are going easterly direction. What will be the longitude of B? We don't know. So to find longitudes, you have to draw. I have told you, or you may have heard me saying this in many quiz or other lectures. I keep repeating this point. To find longitudes, always draw the earth from the north pole. This is a 0 degree meridian. This will be your 180 degree meridian, anti-meridian, 90 east, 90 west. So this is what you look at earth from the top or the north pole. Now let's point 165 east, that is location A, will be somewhere on the eastern hemisphere, so 165 east. Position B I don't know, but I know the D long between them is 40 degree. Okay, this I know, which is 40 degree, and we are going easterly direction. So easterly directions are always anti-clockwise directions. When you look at the earth from the north pole, easterly directions will be anti-clockwise directions. That means your point B or location B can be somewhere here or it can be somewhere here, somewhere here. So anywhere to the left hand side of location A. Anywhere to the left hand side of location A. So let's see what can that location be. So from the figure here, you can see the difference between 180° east and 165° east is how much? It is 15°. So total D long is how much? 40°. Out of that I am going to subtract this 15°, because from A I will cross this 15° longitude and I will reach anti-meridian 180 east. So how much is left? It is left 25° of longitude difference is left. So the 25° of longitude will be covered in traveling from 180° anti-meridian to the western hemisphere. So from here you will come down 25° change in longitude. So next step will be from 180° meridian, you will subtract 25°, you will get 145°, 155 degree. So that means your new longitude of B is 155 west. 155 west. So the difference between them 180 and 155 is how much? 25. So now you can see this condition is satisfied. The difference between location B and 180 is 25° longitude difference. A and 180 is 15°. Addition of them is how much total? 40°. So the new longitude of B will be 155 west. 155 west. Remember this. Okay. So this is how we found great circle from B to A. Very simple. This is how we found the longitude of B, which is 155 west. 155 west. First, find convergency. Find D long, 40°. Step number 2, draw the diagram here and here. From here you will come to see in which direction you are flying. Easterly direction. Okay. So easterly directions are anti-clockwise. That means from the left of A, your location B is located to the left of A. So out of total 40° longitude, 15° was spent here traveling from eastern hemisphere to anti-meridian, and the remaining 25 was spent or traveling from 180° anti-meridian in the western hemisphere. Okay. So 180 minus 25 will give you 155° west. It can be little difficult in the beginning, but it is very easy as you keep on practicing new and new sums. Let's go to question number 3. The rhumb line from position D to position C is 0, 9 or 0. That means both are located at same latitude. The great circle track from C to D is 287. So let's plot this. Plotting is the only way. So straight line means 90, 270 easterly, westerly. So D to C is 0, 9 or 0. So D to C is your rhumb line track, considering this is your northern direction. So this will be your east, this will be your west, this will be your south. So D to C 0, 9 or 0. The hemisphere is what? North hemisphere. So in the northern hemisphere, the great circle will go from the north pole. So this is your great circle, your rhumb line. Let's label it. Rhumb line D to C was 0, 9 or 0. And great circle from C to D was 287. Great circle is this much, this big. The total angle is 287. Okay, very easy. Now let's find what is the great circle track from delta to Charlie. Very simple. Now look at this over here. We have great circle track from C to D, how much? 287. What will be the Rumline track from C to D if I want to come from Charlie to delta? It will be the reciprocal of Rumline track, reciprocal of Rumline track from delta to Charlie. Correct? That means reciprocal of 090. So Rumline from C to D will be how much? 270 degree. So C to D is 270, D to C is 090. So now we have two information. Great circle from C to D is 287. Rumline from C to D is 270. So conversion angle will be how much? Conversion angle is the difference between Rumline and great circle. C to D, C to D. Both must be the same. So 287 minus 270 is 17 degree. So that means this much is 1717. Now we can answer the question. Great circle from delta to Charlie will be great circle from delta to Charlie will be only this much, right? So out of this total big angle, only the upper part is great circle, touching this starting from vertical line up to this line where great circle is there. So total angle is Rumline angle, which is delta to Charlie minus this part. So out of the total big angle, I will minus 17, which is your conversion angle. So 90 minus 17 is 073 degree. So great circle from delta to Charlie is 073 degree. Easy. What is the latitude and longitude of position Charlie? Approximate. Now since they are both are located at same latitude, the latitude of delta will be equal to latitude of Charlie. Both are at same latitude, and the reason being and Rumline from D to C equals to 090. Rumline from C to D equals to 270. So this logic is enough to determine that both latitudes are same. So latitude of D is 30 degree north. So latitude of C will also be 30 degree north. So this is the next part of the next answer of the second part answer. What will be the longitude? Now longitude of delta is 179 west. So let's take a new slide. So same, whenever we are told to find longitude, your first duty will be to draw a circle. Northern pole, 0 degree meridian, 180 degree east hemisphere, west hemisphere, 90 east, 90 west. Delta is at what latitude? Longitude 179 west, means very close to 180 degree west is where your delta located. Now in which direction are you going? From delta to Charlie, you were going in the direction of 090. That means you are flying easterly, and easterly directions are always what? Easterly directions are always anti-clockwise. So delta is your starting point. Okay. So delta being your starting point, you're flying 0900 to go to your destination Charlie. So your destination Charlie will be anywhere to the left hand side of delta. Okay, following this anti-clockwise direction, it can be anywhere here, here, anywhere. Okay, so let's find out. Let's write the convergency formula. D long into sine of lat. So convergency angle was 17 degree. Convergency angle 17. So convergency is twice of convergency angle, which is 34. So 34 equals to D long into sine 30. Let's confirm yes. So D long is equal to 34 divided by sine 30, which is equals to 34 divided by half. So D long in degree equals to 68 degrees. So that means aircraft will travel 68-degree difference of longitude to arrive at destination C. Okay. So now this is simple. 179 degree. As you travel left hand side, as you travel anti-clockwise, I told you before, anti-clockwise directions or left hand directions, as you go towards the left, your angles decrease or your directions will decrease. So if D is 179 degree west, location C will be the east of D. Therefore 179 degree minus D long, which is equal to 179 minus 68. So location of C, longitude of C approximately will be 111 degree west. Okay. So latitude of C 30 degree north, longitude of C 111 degree west. Okay. So this is how you do this sum. So quick recap, to find great circle from delta to Charlie, we had to find convergency angle. So we started with rhumb line from C to D, then we found a difference between both of them, and then we used that difference to subtract it from rhumb line from delta to Charlie, and we got a great circle. Next part was what is the latitude of destination Charlie. Now since both are located at same latitude, or as we can see, the rhumb line track is 090270. That means both are at same latitude by definition, and therefore we have 30 degree, 30 degree north. To find longitude, again we drew these two diagrams, one to determine direction, another to plot everything. Okay, then we found D long. Then looking at the direction, we can determine whether our destination is to the right or to the left. Over here it's easterly direction, so it is all your destination will be to your left hand side always. So now it was, yeah, our departure was already at in Western Hemisphere. So our destination was going to be in the Western Hemisphere itself, because D long is not too much to put your destination to the other side of the globe in the Eastern Hemisphere. So final answer is this.